Hey Math 2 students, today we're going to be on practice 4-5. This is our worksheet from our packet that I gave you before we left, and we're talking about isosceles triangles. So I'm going to give you just a couple of notes today on isosceles triangles. Now some of this stuff you already know and some of this stuff might be a little bit new to you, but I want to start out with some basic vocabulary. An isosceles triangle is when at least two of the sides of a triangle are congruent. So in this triangle I've drawn here, I've got that this side is marked with the same marking as this side. That means that these two sides are congruent. The two sides that are congruent are called the legs. Now the third side that is not congruent to the others is called the base. And I want you to notice in this other triangle, it doesn't matter how your triangle is turned, the two sides that are marked congruent to each other are the two legs. The third side is what we refer to as the base. Now, not only do you have segments or sides in triangles, you also have angles. The two base angles that I have in red here, the two base angles would be the angles that are between the leg and the base. So there's a base angle between this leg and this base. Here's a second base angle that's between the other leg and the base. The two base angles are going to be equal. Now guys, the great thing about having a video is if you need to pause it or go back, take notes, you absolutely can do that. So with isosceles triangles, if two of the sides or the two legs are congruent, then you should have two angles, which are the base angles that are congruent. Now the other angle that's kind of sandwiched between the two legs here, that is called the vertex angle. So it's really important before we begin that you know this vocabulary. The legs are the two congruent sides, the base is the other side. The base angles are two congruent angles, the vertex angle is the other angle. In this figure here, you've got two congruent base angles, and then the angle that's stuck between the two legs is your vertex angle. Now, we already know that three angles inside of a triangle all have to add up to be 180 degrees. So if you will look at the very first example on your worksheet, because these two base angles have the exact same markings, that implies that this is an isosceles triangle. So that side and that side have to be the exact same thing. Because the base angles are congruent, that means X and Y have the exact same value. So if I were to take all three of these angles and add them up together, I know that they all have to add up to be 180 degrees. Now this vertex angle has been given to me as 110. So if I take 180 degrees and subtract the 110 degree vertex angle, that leaves me 70 degrees left over. Now that 70 degrees has to be split up between both of these angles, so all I have to do is divide 70 by 2 to get each one of those angles. So it's important to remember that all three of those angles, the two base angles plus the vertex angle together, have to add up to be 180 degrees. Okay? The next thing that I want to talk to you about is some of the properties of isosceles triangles. Okay? If you know one of these three pieces of information, then you actually can use all three pieces of information. So let me go through this again. This is for isosceles triangles. So if you look at the picture I have here, all three pictures are identical. You have a large isosceles triangle. The two legs are the same. And then you've got base angles that are the same. So I'm going to go through this and show you how if I start out knowing that I'm perpendicular to the base, I also know the other two. So let's do this one first. Let's say that this segment that I have drawn here is perpendicular to our base. Remember, you've got your two legs, and then that third side is the base. If I draw a segment that is perpendicular to that base, that forms a 90-degree angle. So I want you to look at what we did yesterday. Remember yesterday when we proved that two triangles could be congruent? Do you see how you have two angles and then you have a side? We've got the right angles that are congruent to each other, the base angles that are congruent to each other, and then you also have these sides. So I could prove that these two triangles are congruent by the angle-side method. And if these triangles are truly, in fact, reflections of one another, doesn't that mean that this missing segment here would have to be the same as this one? If these two triangles are congruent and I can just reflect one to the other side, then that side has to be the same as that side. This tells you that you have bisected the base. Do you see how this base has been cut into two equal pieces? That's what the word bisect means, is two equal pieces. Now also, if this triangle on the left is congruent to the triangle on the right by the angle side method, doesn't that also mean that this little angle here, if it reflects over, would have to be congruent to this angle? That proves the third one, that you would bisect that vertex angle. These two pieces are congruent. So you can see that if you start out knowing that you are perpendicular to your base in an isosceles triangle, that also tells you that you're going to bisect the base into two equal pieces, and you're going to bisect that vertex angle. Now, let's look at what happens if we start out knowing the second one. Let's say that we start out knowing that this base had gotten bisected, that that side is the same as that side. Now, how could you prove that these two triangles are congruent? I've got a side congruent to this side. I've got the base angle congruent to this base angle. And if I know that this base got bisected, I have another pair of sides. So therefore, I could prove that the left triangle is congruent to the right triangle by side, angle, side. Now, after I know that these two triangles are congruent, now I can add in the extra stuff. If this angle is going to be reflected over to match this angle, that tells me my vertex angle has been bisected. And if this angle has to equal this angle, and they're both add up to be 180 degrees, then they are each 90, which means it's perpendicular. Okay? So in the last one, I'm going to start out just knowing that I've bisected that vertex angle. So let's say I give you that this angle is the same as this angle, and the vertex angle got bisected. Now look at this figure here. How could I prove that the triangle on the left is congruent to the triangle on the right? Well, I've got a pair of angles. I've got that leg is the same as that leg, and then I have my base angles. So this time I could use angle, side, angle. That is a way that I could prove that the triangle on the left is congruent to the triangle on the right. Now, if these two really are congruent, doesn't that mean that that side reflects over and has to match that side? Yes. And that angle reflects over to match that angle. So if these two angles are congruent and they have to equal a full 180 degrees, then they're each 90. So therefore, if you start out knowing one of these three pieces of information, you actually can add in all three. So we're going to apply this to the worksheet that you have to do for homework tonight. If you have any questions, remember you can email me, you can give me your number and I can call you and we can talk. Please just take your time, do your best, and let me know if you have any questions.